Hello everyone, welcome back. In this video, we will discuss the valve system, a direct competitor to free valves and pneumatic valves. This valve system is the desmodromic valve actuation. This valve configuration is the pride of Ducati. Desmodromic is a valve system design that is certainly very unique, because in this desmodromic valve system, the camshaft will work multifunctionally to open and close the valve, which is amazing because the valve can return to closing without needing help from the spring. So if in a standard valve system, the valve will be pushed by the lobe on the camshaft to open and pushed by the spring to close. In this desmodromic, the valve will be directly tied to the camshaft. But before we going further about understanding the valve system, where did this sophisticated valve design start from? For its history of birth to fame, desmodromic was first introduced by an engineer named Gustav Mess. When the idea was thought of, it was immediately patented in 1896. And after doing quite a bit of research, it took quite a long time. Gustav finally made the first prototype of desmodromic, which he installed on the speedboat named Erin 1 in 1910. His invention took more than 10 years after the patent was made, but amazingly, although the Erin 1 speedboat engine is the first to use desmodromic technology, its power output is very satisfying. It can produce up to 380 bhp. So there is no word back to the labs again for this version. And also we can say for a century-old engine, at this time we can still say that this is a power with fantastic count. Seeing the great power potential, this technology finally began to adopted in general vehicles like cars and motorcycles, especially for the purpose of the Grand Prix, like the Mercedes-Benz W196 in 1945, then developed again for the Mercedes-Benz 300 SLR sport car in 1955, until finally, a Ducati engineer Fabio Taglioni fell in love with this very exotic valve concept. Of course, he intended to apply for a patent and develop this desmodromic technology, and Ducati first installed this technology on their motorbikes with a capacity of 125 cubic for the Grand Prix competition in the 1916s, making the Desmodromic 125 the first motorcycle with desmodromic technology. And Fabio Taglioni also said, the primary purpose of desmodromic is to force the valve to work according to its timing as consistently as possible. We think that means there is no valve floating. Then the statement is also continued again. In this way, the energy loss is negligible and the performance curve is more uniform with better reliability. This is where Fabio believes that the technology he used can be the best engine technology ever in terms of power. And after Fabio's success, he developed a desmodromic and increased strong sense of belonging. He also began to make several patents for several development of the desmodromic, which has made desmodromic a hallmark of Ducati products since 1957, which was introduced through the White Case Mark III single cylinder for the first Ducati mass production. But besides Ducati, there is also a car manufacturer that adopted this technology in 1959, namely the Maserati brother, who made the first and the last car to use this valve system, which is applied to 2-liter 4-cylinder engine configuration on OSCA Barchetta. But after that, I don't know why this technology was not used anymore for the 4-wheel vehicle. What's wrong with desmodromic technology not being so advanced for the 4-wheeler? So for you who know the reason, or even know what car use the desmodromic valve system nowadays, you can share and let us know via the comment column below. Well, that's a bit of history of the birth of the desmodromic. Now let's start to discuss the parts and also the working mechanism. The desmodromic, if we look at glance, it looks more complex than another valve system, but in reality, it's more simple if we compare with the general valve system or free valve and pneumatic valve. This desmodromic consists of the camshaft for the first part, but as you can see, the camshaft has a distinctive shape, which is different from the camshaft in the general valve system. If you look in detail, this camshaft not only has one lobe on each valve, but this desmodromic camshaft has two cam profile with different cam lobes to control each valve, namely the opening lobe and also closing lobe, which is the form has a very precise calculation. The next part is the upper rocker arm, lower rocker arm, and spring to help closing precisely. And the last one, of course, the valve. Then just like that for the main parts. Now we can continue again with the working mechanism. For the working mechanism, Desmodromic has a working system that matches its name. The meaning of the name Desmodromic comes from two words. Demos is mean relationship or bound, and the meaning of dromos is path. So from here we can conclude the Desmodromic is a valve system attached to the camshaft and also work by following the groove or profile of the camshaft. For more detail, more or less like this. When the engine starts working, the opening and closing lobe lamps will move the upper and lower rocker arm. The movement of the lamp from the opening lobe will move the valve to the open position. After the rocker arm has passed through the bump profile, the lower rocker arm following the closing lobe will also pry to the valve and move the valve to closed position. More or less like that. It's so simple if we compare it with another valve system. But that Desmodromic has its own advantage and disadvantage. So let's start with the advantage first. For the first advantage, the max rev is higher when compared to the SOHC and dohc valve system until now. This is proven by the first Ducati engine we mentioned earlier, the 125 Desmo, with a Desmodromic 2 intake and 1 exhaust valve configuration. The 125 Desmo can produce 19 horsepower with a max rev of 3000 RPM. At that time, the engine still using the steel spring could only reach 8000 RPM. This makes this 125 Desmo an engine that can produce the highest max rev at that time. Likewise now, we just a Ducati engine with Desmodromic technology that is predicted to produce a max rev up to 18,000 RPM, enough to compete with pneumatic valve but with a much fiercer valve response. Furthermore, the engine speed is lighter because it does not require power to press the spring in every rotation. The engine power will be maintained start from the low rate to the high rate RPM. And the third advantage is that there is no floating valve because the valve will open and closing following the cam lobe on the cam profile forcibly. Of course, this condition makes the Desmodromic engine so full of power. Okay, that is for the advantage. Now the disadvantage. The first disadvantage, Desmodromic has a low durability when compared to the valve that use springs. This is due to the greater surface friction between its components. Not to mention, the high rotational speed doing damage to this valve will reduce the density of the valve when it closes, as wear and tear occur with the time of use. However, this can be overcome by the presence of a small spring on the side. And the second disadvantage is the engine response that is too fast. Where this fast engine can, of course, be transformed into superiority and also a weakness at the same time because there is no load from the steel spring and the engine does not experience valve floating. The effect of this engine, valve can work without delay because of this, which makes the reason the Ducati engine is wilder. And of course, only a few racers can beat the Desmodromic valve engine because of the wild engine. Especially when you meet a turn, the warm gas pedal can be dangerous. What currently more exciting is that Ducati is fixing it by improving its aerodynamic and make the motorcycle more stable and cope with a fierce and response engine. So for the conclusion, this valve system is the simplest and has excellent power, but with side effects that are too wild and very difficult to control. Okay, we think that's enough for our video this time. Don't hesitate to use the comment columns below if you have questions or to make corrections. I'm Karir, see you later and thanks for watching.